Have you ever wondered what a digital detective really sees when they look at a computer? It's definitely not just the files and folders you and I see. Nope, it's a hidden world of digital fingerprints, ghosts of deleted data, and all sorts of secret codes. So today, let's open up this toolkit and explore the crime scene that is a computer's hard drive.
We're kicking things off with this quote because, honestly, it says it all. In digital forensics, what you don't know can and absolutely will hurt a case. Fancy software is great and all, but if you don't understand the fundamentals, you could misinterpret a key piece of evidence, or miss it completely. The stakes are just incredibly high.
All right, here's our game plan. First, we'll survey the digital crime scene. Then, we'll see how the machine actually wakes up. After that, we'll decode the secret language of data, figure out all the places evidence can hide, and finally, we'll tackle the biggest challenge of all, cracking the code.
The thing is, having the most expensive, high-tech tools just isn't enough. It's kind of like having a super-powered magnifying glass but having no idea what a clue even looks like. An investigator has to understand the deep-down structure of the hard drive, the digital crime scene itself, because what you see on your screen, that's almost never the full story.
So, where does any digital investigation really begin? Well, at the very beginning, the boot process. Have you ever really stopped to think about what happens in those few seconds after you hit the power button? It feels like magic, right? But for an investigator, that little startup sequence is the very first chance to grab some crucial clues.
It's actually a pretty straightforward three-act play. First up, a little electrical pulse zaps the CPU, the computer's brain, and wakes it up. Then, the CPU runs a quick check called the post to make sure all the hardware is plugged in and working. And finally, once it gets the all clear, the system starts looking for an operating system to load up and bring the whole thing to life.
Now here's where it gets interesting. There's this tiny battery-powered chip called the CMOS. Before Windows or macOS even think about loading, an investigator can pause the boot up and peek at this thing. It holds the computer's fundamental truths, its internal clock, the way its drives are configured, the basics. It's basically the system's birth certificate.
And this isn't just a technical detail, it matters in the real world. Take the case of Zacarias Moussaoui, who was a 9/11 conspirator. His laptop lost power before the CMOS data could be properly examined. That meant the original time and date settings were gone, which could have been a huge issue for authenticating evidence later. Lucky for them, an agent had jotted the settings down earlier, which saved that crucial piece of information.
Okay, the machine is on. Now we have to learn how to speak its language. And here's the wild part. Everything, and I mean everything, on a computer, from an email to a 4K movie, is really just a gigantic string of ones and zeros. To be a digital detective, you have to be fluent in binary.
If you get this classic geek joke, you're already halfway there. In binary, 1-0 is actually the number 2. See, all digital data is built from these simple bits. But how they're grouped together and how they're read, well, that's where the real detective work begins.
And this right here is a perfect example of why you have to know your machine. Depending on the computer's architecture, if it's big-endian like an old Mac or little-endian like most PCs, it will store the very same number in a completely reversed order. Think of it like some languages writing left to right and others writing right to left. Same info, just looks totally different.
Just take a look at this. This shows data captured from 2 different computers at the exact same time. The hexadecimal code you see represents the same date, May 10, 2003. But on the Sun system, the bytes are in one order, and on the Intel machine, they are totally flipped. If an investigator doesn't know to look for this, they're not going to see a timestamp, they're going to see absolute gibberish.
Okay, so let's get to the heart of it. Where does all this data actually live? The hard drive. That is the main crime scene. And trust me, it is full of secret closets and hidden crawl spaces that only a trained investigator knows how to find.
The easiest way to think of a hard drive is like a stack of tiny record players. The vinyl records, those are the platters. The grooves in the record are the tracks. Now imagine chopping each groove into tiny little pieces. Those are called sectors. And your operating system grabs a few of those sectors and puts them together to create a cluster, which is the smallest box it can put any of your files into.
And this is what it all looks like under a microscope. How cool is that? Those ridges and valleys you see aren't random. They are the actual physical ones and zeros written onto the platter with a tiny magnetic head. It's kind of mind-blowing to see the idea of a bit become a real physical thing.
And that brings us to what is probably the single most important concept in all of digital forensics:
Listen closely. When you delete a file, your computer doesn't actually wipe the data. All it does is take down a little signpost that points to it, and it marks that space as available for rent. But the ones and zeros, they stay right where they are, just waiting to be found.
So remember those clusters, the little boxes where files are stored? Well, what if your file is really small and doesn't fill up the whole box? That leftover space is called file slack, and what's hiding in there? You guessed it, fragments of whatever old, deleted file used to be in that spot. It's like finding a crumpled up note from the last person who sat at your table in a restaurant.
So if all the signposts pointing to the files are gone, how in the world do detectives find these ghost files? They use a really cool technique called file carving. It basically means they ignore the file directory completely and just scan all the raw ones and zeros on the entire drive, looking for the telltale signatures that mark the beginning and end of a specific type of file.
And here's exactly what that looks like. A JPEG image file almost always starts with this specific hexadecimal code, FFD8FF. File carving software sees that signature and it knows, aha, this is the start of a picture, even if the file was deleted weeks ago, or even if it was renamed to something innocent like my_homework.txt. It's like the file's digital DNA.
Okay, this brings us to the final and toughest challenge. What happens when a suspect doesn't just delete their files, but they actively try to make them disappear using really sophisticated methods? This, my friends, is where the digital cat and mouse game gets really intense.
First off, we've got to be really clear about the difference between hiding data and encrypting it. Hiding data is just simple camouflage. Renaming an incriminating photo to make it look like a boring system file. Forensic tools can see right through that. Encryption, on the other hand, doesn't hide the data. It locks it away in a mathematical vault that's almost impossible to open.
And there are basically two types of these digital locks. Private key encryption is like your house key. You use the same key to lock and unlock the door. It's fast, but you've got the problem of how to safely give a copy to somebody else. Public key is more like a mailbox. Anyone can drop a letter in through the public slot, but only you have the private, unique key that can actually open the box and read the mail.
At the end of the day, strong encryption is the digital investigator's brick wall. In one major case, investigators were tracking suspects who suddenly started using encryption, and it hindered the investigation so much that not even the FBI could break their code. The evidence was right there, sitting on the hard drive, but it was locked away, maybe forever.
And all of this brings us to one final big question. We've seen how data sticks around in file slack, how deleted files can be pulled out of thin air, and how every little setting leaves a trace. It really makes you wonder, in this digital world that we all live in, does anything we do ever really truly disappear?